Hello friends, welcome back to my channel ProSkill Academy. In our previous videos, we have discussed about the concept of ACF, different methods on how to find out the ACF, and also about the concept of LCM. If you have not seen my previous videos, I have given the link to the playlist about ACF and LCM in the description box. Please go to the link and watch the previous videos. And also, if you are new to the channel, I would request you to please subscribe to the channel so that I can bring you more such interesting videos. Now, coming to the topic of today, that is different methods to find the LCM. Now, there are quite a few methods with which we can find the LCM. We are going to discuss three prominent out of them. The first one is being the listing multiple methods. Then we shall discuss about the prime factorization method and then the division method. We shall also see the examples with all these methods and then practice few problems in our upcoming videos. Now coming to the listing multiple methods, let me first revise. When we talk about the least common multiple, that is LCM, we mean the smallest number two or more numbers can divide without leaving remainder. So that's the core concept of LCM. Now one of the simplest ways to find it is by using what is called as the listing multiple method. The idea is straightforward. We start by writing the multiples of the numbers we are working with. So what we do is that basically we write down the multiples of the numbers. By doing this, we create the list of values. Once the lists are made, we look through them to find a number that is common to all of them. The very first or smallest such number that appears in all the list is what we call the least common multiple. To put it step by steps, first we note down the multiples of the first number. Then we do the same for the second number, that is we list the multiples of the second number, and if there is a third number we repeat so. Finally, the smallest number that is common to all becomes our least common multiple. So we shall compare the list of multiples and find the numbers that appear in all the list. Select the smallest such number, which means we have to select the smallest number which appears in all the list, and that number is nothing but the LCM. So let us try an example. Here it is said that to find the LCM of 4 and 6 using the listing multiple methods. So the first step being that we shall list down the multiples of first number first. The first number here being 4. So the multiples of 4 are 4, 8, 12, 16, 20, 24 and so on. Similarly, I can list down the multiple of 6. So the multiples of 6 are 6, 12, 18, 24, ... Now if you see here, 12 comes in list of 4 also and list of 6 also. Also 24 comes in both the list. But out of 12 and 24, 12 is the number which is least. So 12 becomes the LCM or the least common multiple between 4 and 6. I hope this method is clear to you. We shall also practice many more problems with this method in our upcoming videos. Now let's look at the next way of finding the least common multiple, the prime factorization method. Unlike the listing multiple method, which involves writing down long lists, this approach works by breaking each number into its prime factors. Prime factors are simply numbers that can't be broken down any further. Like for example, 2, 3, 5, 7 and so on. Here's how the process works. To find out the LCM, first we take each number and express it as a product of its prime factors. So we do this for the numbers for which we have to find out the LCM. Now once we have the prime factorization of all the numbers, we look at the prime numbers that appears in the list. And then for every prime number, we select the highest power of that prime number that appears in any of the numbers. Finally, we multiply these chosen prime factors together. The result is the LCM. The beauty of this method is that it is systematic and efficient. It works well not just for small numbers but also for large ones, where listing multiples would become tedious. So in short, take the highest power of each prime factors, then multiply them to get the LCM. This method is widely used because it gives us a clear and reliable way of calculating LCM, and it connects well with the concept of prime numbers, which forms the building block of all integers. Now let us take an example. So here it is told to find the LCM of 8 and 14. Now 8 can be broken down into its prime factors in this way. We start with the smallest prime number, that is 2, and start dividing 8. So 8 divided by 2 is 4. Then again 4 is divisible by 2. So I will again divide 4 by 2. I get 2 again as an answer or question. So I'll divide this 2 again with 2 and I'll get the quotient as 1. So 8 can be expressed as 2 cubes. So 3 times, the 2 appears 3 times. Similarly, if I break down 14, I can first divide it by 2. I get the result as 7. And hence 14 can be represented as 2 into 7. Now there are two prime numbers, or if I take it individually, in the list of 8 and 14, the prime number 2 appears, and the highest power to it is 2 cube. Hence I will take 2 cube first, and then 7 appears in list of 14 and the highest power of it is 1. So I will do 2 cube into 7. So 2 cube is 8, then multiplied by 7, which will give me 56. Hence LCM of 8 and 14 can be written as 56. So you have seen how we can basically use the prime factorization method to find out the LCM of two numbers. Now coming to our next method, that is the division method. In this approach, instead of writing down long list or doing prime factorization separately, we place all the numbers together in a row. Keep dividing them by prime numbers step by step. So what it is said here is that we divide the given numbers by their common prime factors whenever possible, and if a prime number divides only one number, we still write the other numbers unchanged in that step. We keep on doing this until all numbers reduce to 1. Okay. Then the LCM is nothing but the product of all the divisors used in the process. The same steps are written here. I would show you an example. So here it is said that find out the LCM of 12 and 18. So I'll write down 12 and 18 together. Then I will start dividing it by prime number, starting from the lowest prime number, that is 2. Now if I divide 12 by 2, it is 6, and then 18 by 2 is 9. Now as I said previously, that I will keep on dividing even if one of the number is divisible by the lowest prime number. So I will again divide this by 2 and I'll keep the other one unchanged. So 6 divided by 2 is 3 and 9 remains as 9. Now I can divide this 3 and 9 with 3, because they are no more divisible, none of them are divisible by 2 anymore. So the result would be 1 comma 3. I'll do this again and then I'll get 1 comma 1. Now here if you see the multiplications, if I do of these prime numbers, I get 2 square into 3 square, that is 4 into 9, which will give me basically 36. Hence the LCM of 12 and 18 is 36. So these are the three methods for finding LCM. We shall extensively use them in our upcoming video to do some problem solving and also see some real life problems related to LCM and ACF. So please stay tuned, and until then, thank you and see you in our next video.